Alright, so today we want to look at how we can solve exercise number 1. So let's read the question. Un point M décrit la trajectoire. La trajectoire représentée ci-dessous et dans l'équation polaire s'écrit. So we have the equation polaire. Où B est une constante positive. T is greater than or equal to 0. The angle phi is between 0 and pi degrees. Then the first question is saying, définir en un point quelconque de la trajectoire les variables ρ t et phi t dans la base u ρ, u phi. Exprimer dans la base polaire le vecteur vitesse du point M. On note TNB, la base de serré freinée. Exprimer les vecteurs T, N et B dans la base cylindrique. Déterminer le rayon de courbe U. Exercise 5. Calculer la distance parcourue par le point M. Calculer la distance parcourue par le point M. So let's look at the first exercise, the one where we're supposed to définir en un point quelconque de la trajectoire les variables polaires ρ t, phi t dans la base polaire. So how are we going to do that? So actually, the solution is very simple here. The solution is very simple. The first thing that we want to do is to, first of all, draw the diagram for us to be able to définir en un point. Okay? So the first thing that we want to do is to draw the diagram. So I'll draw the y-axis. Then I'll also draw the x-axis. So I'll draw the y and x-axis. So this is my y-axis. Then this is the y-axis. This is the x-axis. Okay? This is the x-axis. Then the unit vector along the the x-axis is going to be the vector ux. The unit vector along the y-axis is going to be the vector uy. Let's look at the trajectory of our particle. So if you look at the diagram from the question, the trajectory is represented as follows. So this is coming like this and then ending here. So we are supposed to represent where is the ρ going to be, where is the angle phi going to be, okay, and where are the unit vectors going to be for la base pour la base polaire. Now the first thing that we want to do is, now if le sens du mouvement is indicated by this arrow that I've drawn here, the first thing that we want to do is to choose a point anywhere on this trajectory. If you want, you can choose a point here. If you want, you can choose a point here. If you want, you can choose a point here. If you want, you can choose a point here. So you are free to choose a point anywhere you want. You are free to choose a point anywhere you want. Now I'll choose a point here. I'll say my point M is located here. This is where my point M is, here where I've drawn the dot. So this is where I want to represent my point M. The next thing that I want to do here is to draw a line connecting the origin and the point M, a straight line connecting the origin and the point M, like so. Well, actually, if you draw this, this is what your ρ is going to be. This is what your ρ, it depends on t. This is what the ρ is going to be. This is what the ρ is going to be, because it is the distance from this origin to M. And then you can see that this distance is not constant. So as the particle M, keeps on moving, as it moves in this particular trajectory, the distance is not the same. If, for example, if I choose a point here, the distance is not going to be the same from the origin. If I choose another point here, the distance is not going to be the same from the origin. So we can see that the distance here is changing as the point M travels from its rest position, which is here, to its final position, which is here. So you can see that the distance here is changing. So ρ is not constant. Now you've represented. Now the angle phi is going to be the angle formed by this line that I've drawn, the line OM with the x-axis. The angle formed is going to be phi. Then according to the question, this depends on t. This depends on t, okay? So this is the first thing that you're supposed to do. So after doing this, what follows is actually going to be extremely easy. What follows is extremely easy. Now, maybe before you even start solving the exercises, the other thing that you're supposed to indicate here is, where are the unit vectors? Well, the unit vector along the vector OM is going to be known as u ρ. And then the other unit vector in the increasing direction of phi is going to be known as u phi. So this is u ρ, like so, and then this is going to be known as u phi, like so. So if you draw this diagram, you would have answered the first question. Hopefully that was clear. Now, what is the next question saying? Well, the next question is saying, exprimer dans la base polaire le vecteur vitesse du point M. Exprimer dans la base polaire le vecteur vitesse du point M. So like I said yesterday, before you even calculate the velocity, you calculate the acceleration, you calculate, before you even do anything. After understanding the diagram, or maybe if the question is requesting you to draw, after drawing the diagram, the next thing you must ask yourself is, what is the position vector? How do I represent the position vector? In this case, they're talking about the polar coordinate system. How do I represent the position vector? So here, if you remember very well, this OM is going to be equal to this distance from O to M, which is going to be rho in this particular case, like so. This distance, rho of t, and then the unit vector in the direction of in the direction of OM. So the unit vector in this particular case is u rho, like so, as simple as that. So that is the vector position. Now here, like I said, rho is not constant. It keeps on changing. The distance from the origin to the point M at different points, you know, in its trajectory, the distance is not the same. So this is actually changing. Even u rho is not constant. Now let me remind you what we talked about yesterday. We said u rho is going to be given by the following. It is cosine phi. It is cosine phi ux plus sine phi uy, like so. Then we also have to understand that u phi is going to be equal to minus sine phi ux, like so, and then plus cosine phi uy, like so. So this is what we have for these two vectors. Another thing that you must remember here is that the derivative of the vector u rho with respect to phi is going to be u phi. Okay, it's going to be u phi. So like we said yesterday, it's going to be u phi, like so. Then the derivative of the vector u phi with respect to phi is going to be equal to minus u rho, like so. So this is what we said. We talked about these things. And then we also said that the derivative of u rho with respect to time is going to be equal to what? Is going to be equal to the derivative of u rho with respect to phi multiplied by the derivative of phi with respect to time. Now if you evaluate, you get phi point, and then phi point, and then u phi, like so. So this is what you're going to have. Then the derivative of u phi with respect to time is going to be equal to the derivative of u phi with respect to phi multiplied by the derivative of phi with respect to time. Now this is going to be minus phi point u. Now I'm a bit used to e phi. Okay, but I'm going to be consistent here. So I'm a bit used to e and not u. So but for consistency, this is what we can write. So hopefully you remember everything that we discussed yesterday. So we talked about all these relations. Now that we have the vector of position, it's easy for us to calculate la vitesse. Now one thing that I want us to do, I want us to call this reference frame r. We're going to call this reference frame r. So let's now calculate the velocity. The velocity of the point M in the reference frame r is going to be equal to the velocity of the point M in the reference frame r is going to be equal to what? Is going to be equal to the derivative of the vector position of the position vector with respect to time. Or if you look at OM is equal to rho. OM is equal to rho. OM is equal to rho. Rho t. So d dt of rho, which depends on t, and then multiplied by u rho. So this is what we have for le vector position. So we replace here, we substitute the expression. We put the expression for rho t. So the expression is b divided by 2, and then 1 plus cosine phi. Then the angle phi, according to what the question is saying, it depends on t, like so, and then u rho, like so. So this is the expression we have. Now the first thing that you want to do here, before you even take the derivative, you have to expand. If you expand, you also have to remember that this derivative is distributive with respect to the addition sign. So you can distribute the derivative after expanding. Now if you expand, if you say b divided by 2 multiplied by 1, you get b divided by 2. which is a constant. If you take its derivative, you're going to get 0. Now for the second one, you're going to multiply b divided by 2. You multiply it by cosine phi t. Cosine phi t. Okay? And then now you take its derivative. But here it's not direct, because the derivative with respect to time of cosine phi is going to be equal to, we cannot do it directly here. We have to say the derivative with respect to phi of cosine. Now let me maybe push that a little, on the left. So the derivative with respect to time of cosine phi is going to be equal to, we cannot do it directly, so we're supposed to say d phi of cosine phi multiplied by d phi divided by t dt, like so. So la même chose. So this is going to be for sine. So this is going to be, the derivative of cosine is minus sine phi, like so. And then multiplied by the derivative of, this is going to give us phi point. And so finally, we're going to have minus phi point sine phi. C'est très facile. La même chose for sine. So the derivative of sine phi with respect to time is basically going to be equal to what? It's going to be equal to the derivative with respect to phi. Then we're supposed to get, it's actually sine, not cosine. So here we're supposed to have sine. Sine phi, like so. And then multiplied by the derivative with respect to time of phi. So the derivative of sine is cosine. So the final answer here is phi point cosine phi. So you also have to remember these two things. So you have to be very careful here. So this is a very tricky problem. So you have to pay particular attention to how you are differentiating and how you are doing your, how you're doing your differentiation in general. So the first item here, the derivative is 0 because we're going to get b over 2, which is a constant. If you differentiate cosine phi with respect to, with respect to time, you're going to get minus phi point sine phi. So here you're going to have minus b divided by 2, and then phi point, and then sine phi. If you want, you can put the t, but then I'll just be writing phi from now on to sort of like avoid writing a lot of things. But hopefully you get the idea and you're able to see that what I've written here is actually what you are supposed to get, or is what you're going to get. Okay, so this is what we have, like so. So this would be minus phi point minus sine phi. Okay, right. So we've written everything, minus b divided by 2, then phi point sine phi. And then another thing that I forgot to mention here is that we're supposed to apply the product rule, because we have a product of two functions here. So we'll first of all differentiate rho. So this is going to be, we'll first of all differentiate the first one and leave the second one alone. So this is going to be d dt of what? D dt of rho t. And then we leave the second vector alone, u rho, like so. And then plus, we leave the first vector alone, which is rho t. And then we differentiate the second one, so u rho with respect to time. So this is what I've done here. I've applied the product rule. So that's why the second part for the first term, the second vector is untouched. And then I'll have to now leave the second one alone and then differentiate the second. I'll leave the first one alone, then differentiate the second vector. So this is going to be plus b divided by 2, and then 1 plus cosine phi t, like so. And then the derivative of u rho, the derivative of u rho, you go back here, you scroll back up here, you can see that I've reminded you that the derivative of u rho is actually going to be u phi. So this one c'est très facile. So just write it here, you put your most awesome u phi, like so. Now this form, you can leave it, this is the final answer. Yes, you can leave it here. Okay, you can proceed to the other questions, but then this is not very easy to work with. So the questions that are going to follow depend on what? Depend on this answer. So it's not easy to work with this answer the way it's written, especially when we want to calculate things like norms and all that. We want to have, especially since we have a sine and cosine, we want to be able to use this identity. We want to be able to use this identity for simplification. Sine squared phi maybe plus cosine squared phi. Okay, because I know that this identity is equal to 1. So this is what I'm thinking about. Okay, so this is what I'm thinking about, this identity. That is what I want to use. So it's very hard to arrive at this particular form if I leave this answer the way it is. So what I'm going to do is, because it's not possible here to have a sine squared phi and a cosine squared phi, when I later on start to calculate the modulus, the only thing that I can do is to remember these two trigonometric identities, or these trigonometric identities that I'm going to write here. Remember that sine phi is going to be equal to 2 cosine phi divided by 2 sine phi divided by 2. Then also remember that cosine phi is equal to 2 cosine squared phi minus 1, like so. So remember these two identities. So let's plug these into what we have. So this is going to be equal to, so remember here, I'm going to continue my calculation. We want to get rid of this sign that we have here. So I'll put this expression. I'll replace the sign with this expression that I have here. So if I put this expression here, the 2 and the 2 will simplify. Then I'm going to have minus b, then cosine phi divided by 2, then sine phi divided by 2. Okay, so this is what I get. And then u rho one more time, like so. Then if I replace this cosine that I have, the cosine phi, with this expression, you see that the minus 1 and the 1 will simplify. And here what I'm going to get is, I'm going to get plus, then the 2 and the 2 will also simplify. So I'm going to get b. Okay, I'm going to get b, then cosine, so this is divided by 2, sorry. B cosine squared phi divided by 2, like so, u phi. So this is what I'm going to have. So this is what I'm going to have. So hopefully you guys have been able to follow. Okay, so this is what we're going to have. So look at the identities one more time. Look at the identities, and then you'll see, if you look at the identities, that what I've written is actually making sense. What I've written is actually making sense. So here we can see that cosine phi divided by 2 is common, because here I have cosine squared phi divided by 2. B is also common. Okay, b is also common. So what I can do is I'm going to say b is common, and then cosine, and then also there's something missing here in our calculation, because look here, when we were differentiating cosine phi, we have a phi point, like so. When we're differentiating a cosine phi, we have a phi point. And here when we're differentiating we were differentiating u rho with respect to t. So we actually, I thought we were differentiating it with respect to phi. So I got this one. However, if you differentiate u rho with respect to t, you're supposed to get this. Okay, so I made a mistake here. So there's supposed to be a phi point here. It's supposed to be a phi point. Let me write it in a different color. So that I just forgot to include the phi point here. So if you've been wondering why am I not writing the phi point, of course, yeah, I made a mistake. You're supposed to have it there, the phi point. So now that everything has been corrected and that everything looks okay, so you might have been wondering, where has the phi point gone? So I'm including the phi point here, like so. Same, I'm including it here, the phi point. Okay, so so I'm going to have, if I factor, I get the common term. So b is common, and then phi point is common, and then cosine phi divided by 2 is common. Cosine phi divided by 2 is common. And then what are we going to have? We're going to have minus sine phi divided by 2, and then u rho, and then plus cosine phi divided by 2, and then u phi. This is what you're going to get. Okay, so this is your final answer. So this answer is a better form than what we had previously. Let's say you want to calculate the magnitude of this vector. You would have to take the norm here. You have to take the norm. If you take the norm, it is the norm of this constant and the norm of this vector that we have here. So taking the norm of this vector that is in brackets, you have to say sine squared is going to be root of minus sine squared phi over 2 minus sine squared phi over 2 plus cosine squared phi over 2, which is going to give us a 1 inside, and then this is we're going to simplify our calculations. But if you choose this expression here, you're going to have a lot of problems to calculate something like the norm of this vector. So that is why I had to write it in another form. So this is the velocity. So this is the velocity of the point M in the reference frame R. So let's look at the second exercise. What is the second exercise saying? This is actually the second exercise. Let's look at the third exercise. Now here, because I I forgot my phi point somewhere. So let me just maybe go through what we did here so that you see what is happening here. So we're supposed to find the velocity of the point M in the reference frame R. So we'll apply the definition. The velocity of the point M in the reference frame R is equal to the derivative of the position vector with respect to time. Okay, the position vector in this case is rho t, and then multiplied by the unit vector, which is euro in this case. So here we have to apply the product rule because we have two functions here. Okay, we have to apply the product rule. So if you apply the product rule, the first thing is you differentiate the first item, then you leave the second one alone. Then plus you differentiate the second item, then you leave the first one alone. Now here you substitute, you plug in the expression for rho t, which is what I have here. Okay, so yeah, so this from here you go here, but in mind you should have it in mind that you're supposed to apply the product rule for differentiation, and then here you expand. B divided by 2 multiplied by 1 is B divided by 2. If you take the derivative, which is going to be distributive with respect to this addition, the final answer is going to be 0. Okay? If you take the derivative, the answer is going to be 0. Then you now take the derivative of cosine phi. Now you cannot do it directly here. That's why here on the other side I'm saying the derivative of cosine phi with respect to time is the derivative of cosine phi with respect to phi multiplied by the derivative of phi with respect to time. Or the derivative of cosine phi with respect to phi is minus sine phi multiplied by the derivative of phi with respect to time is, c'est une dérivée temporelle, so we're going to get phi point, like so. Okay, so this is what you're going to have, minus phi point sine phi. Okay, so we did that, and then we also carry the phi point, like so. Okay, we don't forget the phi point. Same thing when differentiating euro with respect to time, you won't do it directly. So first of all, we're going to say the derivative of euro with respect to time is going to be equal to the derivative of u phi with respect to phi multiplied by the derivative of phi with respect to time. So this d phi divided by dt is going to give us the angle. It's going to give us une dérivée temporelle, which is going to be phi point, which is what I've indicated here. And then the unit vector, which is u phi, like so. So I'm here. Okay, so you inject everything into this the equation that we have here, and then if you want you can leave the answer here. But then this is not a very useful form, especially when we want to calculate the norm of this vector. So I looked for identities. Sine phi is equal to 2 cosine phi divided by 2 multiplied by sine phi divided by 2. Then cosine phi is equal to 2 cosine squared phi divided by 2 minus 1. Then you inject the two equations into what we have here. You get this expression, and then you simplify. You factorize by you factor out the common terms. You factor out the common terms, and then you're going to have what I have here. So that's the expression for the velocity. That's the expression for the what? For the velocity. Hopefully everything is clear now. So let's look at the third question. Let's look at the third question. So let's look at the third question. So the third question is saying, the third question is saying, let me just go back to, okay, the third question is saying, on note TNB, la base de ces réfrénés, exprimez les vecteurs T, N et B dans la base cylindrique. Exprimez les vecteurs T, N et B dans la base cylindrique. Right. So we want to express the vectors T, N, and B dans la base cylindrique. Okay. Now, is there any formula that you can remember that connects, for example, the velocity and one of the vectors dans la base de ces réfrénés? If you remember what we did yesterday, we said that the velocity of a point M in the reference frame R, the velocity of the point M in the reference frame R is going to be equal to is going to be given by la norme, the norm of this velocity, or the magnitude of this velocity, multiplied by the vector t. So since I know I have the expression for velocity, then because I have the expression for velocity, I can calculate the norm. Okay, then I'll be able to find t. Okay, So I'll find t because I have v. Then because I have v, I can calculate the norm of v. Then finally, I'll be able to find the expression for t. Okay, I'll be able to find the expression for t by identification. Okay, let's first of all calculate the norm, since we need to calculate the norm. Well, we have this expression here. So how do we find the norm? So the norm of the velocity of the point M in the reference frame R is going to be equal to, so we'll say norm, like so, and then we'll put the expression for the velocity. So we'll write it cosine phi divided by 2, and then we have minus sine phi divided by 2, and then euro, and then plus cosine phi divided by 2, and then here you have u phi, like so. So the norm, you can say it is the norm of this constant, because we have a product. So it is the norm of this constant that we have here, which is going to be the constant itself. So b multiplied by phi point, and then cosine phi divided by 2, and then the norm of this vector that we have inside here. So it is minus sine phi divided by 2, and then euro, and then plus cosine phi divided by 2 u phi. So what we have here as a vector is the decomposition in the cylindrical coordinate, in the polar coordinate system. So this is decomposition in the cylindrical in the polar coordinate system. So if you have this expression to calculate the norm, all you have to do is you say b phi point, I'm just going to write it like so, and then it is root of the first component squared plus the second component squared. So it is the first component squared is minus sine phi divided by 2 squared, and then plus cosine phi divided by 2 squared, like so. If you calculate here, you say you have cosine phi divided by 2. If you calculate here, you should have 1. So 1 multiplied by this constant is, so here remember the trigonometric identity. You apply the appropriate trigonometric identity, which is, let me just write it in a different color in case you've forgotten. Sine some angle theta, sine squared some angle theta plus cosine squared the same angle theta is going to be equal to 1. Here our theta is theta divided by 2, so it works. I mean our theta here is phi divided by 2, so we can still apply this trigonometric formula here and you get 1. Now 1 multiplied by what we found, 1 multiplied by the other constant, we're going to get the other constant, which is b phi point, then cosine phi divided by 2. Now that is the norm. Okay, so let me write the full equation. So we now know the norm. We also know that the velocity of the point M in the reference frame R, dans la base de ce réfréné, it is going to be equal to the norm of this velocity in the reference frame R, and then multiplied by the vector t. So let's now write the full expressions. Let's now write the full expressions. So here we have b, and then we have b, and then we have phi point, like so, and then we have cosine phi divided by 2, like so, and then we have minus sine phi divided by 2, and then we have euro, and then plus cosine phi divided by 2, and then we have u phi, like so, and then this is equal to, well, the norm, we found the norm, it is b, the norm it is b, and then we have phi point, and then cosine phi divided by 2, and then multiplied by the vector t. Now what we have here, let's now compare here. This part that we have here, we have it here. Okay, so for these two vectors to be equal, for these two vectors to be equal, it means that the vector t has to be equal to whatever I'm seeing here, which is minus sine phi divided by 2 euro, and then plus cosine phi divided by 2, and then u phi, like so. So you would have found that is how you find the vector t. That is how you find the vector t. So hopefully it's clear. So let's now find the vector n, because we're supposed to find all the 3 vectors. Let's now find the vector n. So how do we find the vector n? So we'll remember the expression where n is found. So it's not the relationship between the velocity and the vector t, but it is in the in the formula for finding the acceleration, where we're going to get the answer. Now let me remind you that the acceleration dans la base de C réfréné, the acceleration of a point M in the reference frame R is going to be given by, dans la base de C réfréné, it is going to be given by some tangential component plus then an, and then so this is the normal, this is the tangential component, and then this is the normal component. Okay, so this is the relation we're going to use to be able to solve the current problem, okay. Then let's also remember that what the expression for AT is and what the expression for AN is. We said that this AT is equal to the derivative with respect to time of the norm of the velocity of the point M in the reference frame R. Now, to be able to simplify things here, I'll say we're going to pose V is equal to the norm of the velocity vector in the reference frame R. So to simplify things, and so we can write this AT as the derivative with respect to time of V. Then, if you remember very well, we said that AN is going to be equal to AN is going to be equal to equal to V squared divided by rho. Okay, but before that, what we wrote is this. Before that was the final thing we got. So I'm not looking for that final thing. So what we can say, we can write the entire normal component. The entire normal component is written as Vm, okay? Vm, Vm, and then dt. So here it's actually V, not Vm, because this is no. I've said on pause, V is equal to that. So this is what we have. Now, why haven't I written the final thing? Because we said that AN is V squared divided by rho. And then now we want to find the vector n. So the full thing here, this is what carries the n, like so. But then we don't know, we have some unknowns here. Okay? So what we can do here is to write the whole thing. This will focus on this component. This component is not useful. So if I also write the whole thing here, and if I include the vector t, this is what I'm going to have. Okay, according to this formula, this is what I'm going to have. So we won't use this one. We won't use this part. What we'll use is this part, because we are looking for the vector n. Well, we already have the expression for the vector t. So since I have the expression for the vector t, I can easily find the derivative of t. Okay, I have t, so I can find the derivative of t with respect to time. I have t, so I can find the derivative of t with respect to time. Okay, and then I also have v. I also have the expression for the norm, okay, which is what I found here. Okay, so everything is there. So let's now continue. So we have an n is equal to an, the full thing is equal to, so we'll introduce the norm a little later. So because I know here we'll run out of space. So d dt of, what is the vector? The vector t, it is minus sine phi divided by 2, and then we have euro, and then plus cosine phi divided by 2, and then here we have u phi, like so. C'est bon? So this is what we have. Bien. So since we have this, let's first of all differentiate. So here we're going to get v. I'll plug in the v a little later. So let's first of all calculate the derivative. So here we have a product. So we'll apply the product rule here. And then we'll also apply the product rule here. So if you apply the product rule here, what are you going to get? And then also remember here that we have phi. So and then you're differentiating with respect to t. So you're not going to go directly. You're not going to go directly, okay? Because we're differentiating with respect to phi. So here, the derivative, let me also write it here. The derivative with respect to t of sine phi divided by 2. This is going to give us phi point divided by 2, and then cosine phi divided by 2. So this is what we're going to get. So same thing, the derivative with respect to time of cosine phi divided by 2 is going to be minus phi divided by 2, minus phi point divided by 2, and then we have sine phi divided by 2. Okay, so this is what we have. So let's apply this here. Let's apply this here. And then we also know the derivative of euro with respect to t. Okay, so here we have v, and then dt. So we first of all differentiate this sign. We differentiate the sign. So the minus here is going to be persistent. The minus is still persistent because it's coming from somewhere. It's not coming from here. So the minus will be persistent. If you differentiate this, you're going to get, now let me just write the full thing. Let me just write the full thing. So here you're going to have minus, and then you have phi point divided by 2. You have phi point divided by 2, and then you have cosine phi divided by 2. And then we leave the euro alone. Okay, that's fine. We leave the euro alone. Now, we'll differentiate. We'll leave the first one alone, which is this one, the same thing. So we'll leave the minus sine phi divided by 2 alone, but then we differentiate the euro. If I differentiate euro, I'm going to get phi point. Okay, with respect to time, that is. I'm going to get phi point, and then I'm going to get u phi. Hopefully, you're able to apply these things properly. So we are done with the first term. Let's look at the second term. For the second term, c'est la même chose. For the second term, c'est la même chose. For the second term, we'll apply the product rule. So let's first of all differentiate the cosine. The cosine is going to come with a negative. So it's going to be minus phi point divided by 2, minus phi point divided by 2, then sine phi divided by 2. Then we leave the second vector alone, which is u phi, like so. And then we leave the first vector alone, which is plus cosine. We leave the first vector alone, which is plus cosine phi divided by 2. Cosine phi divided by 2. What are we going to get here? And then when we differentiate this, when we differentiate, we leave the first vector, we leave the first item alone, then we differentiate the second one. The second one is going to come with a minus. The second one is going to come with a minus. So we're going to have minus, we're going to have minus phi point, minus phi point, minus phi point divided by 2, minus phi point divided by 2, then minus phi point divided by sorry, here we're going to, we leave the cosine alone, the cosine component alone. So we're going to have cosine phi divided by 2. Then if you differentiate u phi with respect to time, you're actually going to get a phi point. You're going to get a phi point, like so. That's what you get. You actually get a phi point here, and then you get your euro here. You get your euro there. Okay? So this is what we get. This is what we get. Okay? So minus phi point cosine phi divided by 2. Let's look at the expression, because we've done a lot of things here so that we don't make a mistake. So we have minus phi divided by 2 cosine phi phi point minus phi point divided by 2 cosine phi divided by 2 euro minus phi point sine phi divided by 2 u phi minus phi point divided by 2 sine phi divided by 2 u phi minus phi point cosine phi divided by 2 u rho, like so. If you simplify, you should be able to get this. If you simplify, you should be able to get, if you simplify and factorize, I'll leave it to you guys to check what the final result is going to be, but I'll just give you the final answer to save to save on time. So you simplify and factorize. If you simplify and factorize and plug in v here, the final answer here will be your n here is going to be minus 3b divided by 2 minus 3b divided by 2 phi point squared, like so, and then cosine phi divided by 2, and then you have cosine phi divided by 2 euro, like so, and then plus sine phi divided by 2 u phi, like so. So this is what you have. This is what you're going to have if you introduce the norm. V is the norm. Let me remind you that V is norm the norm of the velocity. That's what V is. You plug in this value that we found here. We calculated the norm, this value here. You plug in, you get this value, plug it in here, and then simplify, factorize, factor out the common terms, simplify. You'll be able to get what I have here. So this phi point, you can see that there's a phi point in common here. We have a phi point here, we have a phi point here, the phi point here, the phi point here. So it's going to be factored out. You multiply it with this phi point that we have here, you get the phi point squared. Okay? And then check the other common terms, if there are any other common terms, if there are any other simplifications. I'm sure this minus 3 divided by 2 is common, because here you have to simplify this item, you simplify, and this item here. You also simplify what we have here. So you see that you get exactly what we have here. But what are we looking for here? We are looking for the vector n, and we're not looking for an and the vector n. So this expression that is on the right, this expression that is on the right is an and the normal vector n. So to be able to get n, to be able to get the unit vector, we have to normalize what we have here. We have to normalize the expression that we have here. So to be able to normalize, we are supposed to divide. So to find n, we're supposed to normalize this expression here. So we'll divide this expression by the norm of this vector. Okay? By the norm of this vector. So meaning we have to calculate the norm of what we have here. So let's calculate the norm. So the norm of this vector that we have here is what? So you take the norm. So you have minus 3b divided by 2, and then phi point squared, and then you have cosine phi divided by 2, and then you have cosine phi divided by 2, and then euro, and then plus sine phi divided by 2, and then u phi, like so. So this is what you have. And then because you have a product here, you can take the norm. So this norm is going to be, if it's taken on a constant, it's going to be equivalent to taking the absolute value. So you can take the absolute value here. So if you take the absolute value, you have minus 3b divided by 2, and then phi point squared, and then cosine phi divided by 2, like so. And then here we still have norm, and then cosine phi divided by 2 euro plus sine phi divided by 2 u phi, like so. So here it should be clear to you that when you take the norm of this item, you should be able to get 1. If you take the norm, you should be able to get 1. And here if you take the absolute value, remember here I said you split the norm. So it will be the norm of this constant that we are seeing here and the norm of this vector that we are seeing here. If you're taking the norm of a constant, you can just convert the norm into absolute values. So you have this. So taking the absolute value of a negative quantity is getting positive of this quantity. So we just get the positive representation of this expression we have here. So we have 3b divided by 2, phi point squared, and then cosine phi divided by 2 is what the norm is. Okay. So what is the vector n? What is the vector n? So if you want, you can, just like we did just like we have done for the vector of Vitesse, we wrote the whole thing. We wrote the whole formula. So we'll do it here. So we'll do it here. So we have that an, here we have that an n is equal to, well actually this is the, we were finding the norm, sorry. So you write this thing that we have here, okay? You write the full expression on the left. Or we can just apply this formula that I've written here. this formula. I said to find n, which is our unit vector, we have to normalize this entire expression. So when we normalize this entire expression, so we have to divide by the norm. We've calculated the norm. So if you plug it in here and you write the full expression, you see that this term simplifies with what? With this term. This term I have here simplifies with this term. But then the negative is going to remain because the expression that is below does not have a negative. So the negative is still going to remain. Okay? When we divide, the negative is still going to remain, but all the terms are going to cancel. And so this is going to mean that our n, is going to be minus, and then cosine phi divided by 2, and then euro, and then plus sine phi divided by 2, and then u phi, like so. So this is the final answer for n. This is the final answer for what? For n. Or you can say n is minus cosine phi divided by 2 euro minus sine phi divided by 2 minus sine phi divided by 2 u phi, like so. Okay, this is what we have. C'est très facile. Okay, so let's look at the fourth. We're supposed to find. There's one more vector we are supposed to find. There's one more item we must find. We must find one more item. It is the vector b. Now, since you have t, since you have n, we know that b is the vector product of t and n. B is the vector product of t and n. So how are we going to calculate the vector product? So it's very easy. So what is the expression for t? Well, we have the expression for t is minus sine phi divided by 2, and then euro, and then plus cosine phi divided by 2, and then u phi, like so, vectorial minus cosine phi divided by 2 euro, and of course, because I'm running out of space here, just going to continue writing things, down. So minus sine phi divided by 2, maybe a little bit space here. Minus sine phi divided by 2 u phi, like so. Okay, so this is what we have. Right, so b, things are not clear here. Let me write it one more time. So here I'm going to start from this point. So b is equal to t vectorial t vectorial n, like so. Well, this is going to be equal to, now, minus sine phi divided by 2, and then euro, like so, and then plus cosine phi divided by 2 u phi, like so, and then vectorial minus cosine phi divided by 2 euro minus sine phi divided by 2 u phi, like so. Okay, right, so this is what we have here. So how do we now take the vector product? So remember that the vector product, if you want, you can consider this expression as, you can say, if you want to know what you're supposed to do here, you can say, you can let this expression be equal to z, like so. Then you can say z vectorial, so that you simplify. So you can say, so that you see what is happening here, because you might not know what to do. So z vectorial, so you write it as minus cosine phi divided by 2, and then euro, and then minus sine phi divided by 2, minus sine phi divided by 2 u phi, like so. So this is going to mean, remember that the vector product is distributive with respect to a sum or a difference in this particular case. So meaning what you're going to do here is, you're going to say the entire z, you take the vector product of the entire z and the first term, and the entire z and the second term, and the second term. So you're going to say z vectorial. I'm going to call this first term y to simplify things. Then I'm going to call this second term w, for example, to simplify things. So it is z vectorial w, okay, z vectorial w, like so. And then you can maintain the difference here. Z vectorial, this entire thing. So maybe let me just say, I'll put a plus here, and then I'll put this in brackets. Okay, so it's z vectorial w, and then plus z vectorial, y, plus z vectorial w. I've put a plus here. Okay, if you're confused about, okay, is the vector product distributive or what? It's distributive with respect to this sum. So it's also distributive with respect to the difference, because it's easy to introduce a sum here. Okay, it's easy to introduce a sum. So that's what you're supposed to do. Now I'm just going to get rid of this and do the calculation. So just wanted to help you. Okay, I just wanted to help you a bit. So, bien. So we have to take the vector product of this entire thing with the first item. Now look, this is euro and this is euro. So if I take the vector product, it's going to be what? It's going to be 0. Okay, so fine, this is going to mean that I have to write it is, or another way of looking at it is the first term here. You take the vector product of the first term and every term in the second expression, and then after you finish, you take the vector product of the second term with every term with every term in this second expression. So you say the vector product of this first term and this first term is 0, because here you have euro, euro, like so. Then the vector product of the first term and the second term, remember we have a trièdre direct. So meaning we have euro, u-phi, and uz, like so. So this is what we have: euro, u-phi, uz in the cylindrical coordinate system. If you take the vector product in this direction, you get positive the other unit vector. So if I take the euro vectorial u-phi, it is going to be uz in the positive uz. But if I take the vector product in this direction, I have to include a minus. Okay. So if I take the vector product of this first term, of this first term, and of this second term here, I'm going to have this minus sign phi divided by 2, and this minus sign phi divided by 2 will give me sine squared phi divided by 2, and then I can have now euro vectorial u-phi. So you can multiply the constants. The constants, for the constants, you multiply them using normal multiplication, and then for the vectors, you take the vector product. That's what you do here. If you do the same thing, if you look at you are done with the first one, you go to the second one. The second one and the last one will give us 0 because it's u-phi, u-phi. Okay? But then this one and this one is positive, this one is negative. So you multiply the constants using normal multiplication. So you should be able to get minus cosine squared phi divided by 2. And then you have u-phi vectorial euro, like so. Now you have to respect this. Here I'm saying u-phi vectorial euro. So I'm going in the opposite direction. So I must take negative. I must account for the negative. But here euro u-phi is uz. So euro u-phi is uz. So here we have sine squared phi divided by 2 and then uz, like so. Now here I'm saying u-phi euro, I'm going in this direction. So it's going to be minus the other quantity. Minus the other quantity. It's going to be minus the other unit vector. In this case, since it is between I'm taking the vector product between u-phi and euro. The other vector is uz, but then I'll multiply that with a negative because I'm going in the opposite direction. Now with this negative that is here, I'm going to get plus cosine squared phi divided by 2 uz. Now here you can factorize by uz. So this is going to be uz, and then you're going to have sine squared phi divided by 2 plus cosine squared phi divided by 2. So this is going to be 1. famous trigonometric identity. This is going to be 1. So this is going to be equal to uz, like so. Then you have found all the 3 vectors, b, t, n. Okay, b, t, n. And then this makes sense because if you look at, if you understand what what we're going to get when we take the vector product, this vector b has to be perpendicular to both t and n. Now, if you look at the unit vectors for t and n, you see that they all contain u, rho, and u phi. And so it makes sense that the vector b is carried by, that the unit vector in the direction of the vector b is actually the vector uz. Okay? So this is exercise 3. So let's look at the 4th exercise. What is the 4th exercise saying? What is the 4th exercise saying? So the 4th exercise is saying, that we do what? That we déterminer le rayon de courbure, the radius of curvature. So how do we find the radius of curvature? Now, yesterday, if you remember very well, I gave you a formula in terms of when we try to take the norm of the vector acceleration of the when we try to take the norm of the vector acceleration and the when we try to take the norm of the vector acceleration and the vector vitesse, you'll be able to deduce the expression for the radius of curvature. However, there's another formula. You can use this one. So an is equal to the magnitude of velocity squared divided by the radius of curvature. The radius of curvature, which is in this case going to be rho. So we're supposed to make the radius of curvature the subject. So we are going to say radius of curvature is going to be equal to the velocity v squared and then rho. Like, so remember that we said v is the norm of le vector vitesse. We said this, we simplified this calculation. Now, if you remember the norm of v, the norm of v is, it was b, if you look at the expressions we found, it is b phi point and then cosine phi divided by 2 and then we have squared, like so, and then divided by the norm of acceleration. If you check, you get 3b divided by 2 phi point squared and then cosine phi divided by 2. If you simplify here, you should be able to get 2b divided by 3 cosine phi divided by 2. C'est bien. Then the last question is, of course, I haven't shown the board. Sorry. So this is what I was doing. This is what I was doing on the board. I thought I was sharing the screen, the board. Now let me just maybe go through one more time. I said, if you try to take the norm of le vector accélération and le vector vitesse, this you get a formula where you have rho as your radius of rho as your radius of curvature, but you can apply this formula directly without thinking about the one what we had yesterday. You can apply this one directly. So if you apply this one directly, you have to make rho the subject of the formula. So if you make rho the subject of the formula here, what you're going to get is v squared divided by an. Now v squared, remember that v is the norm of the vector vitesse. Then this is the expression we found for the norm of the vector vitesse. Now because we have squared here, we're supposed to square this. And then the norm of the acceleration is, the norm of the vector acceleration is 3b divided by 2 phi point squared cosine phi divided by 2. That's what the norm is. So let me just show you where we found these things, just in case people are confused. Here where we're taking the norm, this is what we have here. I know here I wrote the norm of an, the norm of ann. See, here you can just say this is the same thing as what I've written here is the same thing as the norm of an. Now an is a scalar, and then the norm of n is a unit vector, so its norm is 1. So an is a constant, so the norm of an is an. The norm of an is an. So that's why here I'm saying an is equal to this expression that is here. Okay, so That's why I've written everything the way it has been written. If you simplify, you will get 2b 2b divided by 3 cosine phi divided by 2. So that is what you're going to get. Okay? Bien. Then the last part is saying find the radius of curvature. Find the radius of curvature. How are you going to calculate the radius of curvature? Now, if you remember again, we had a formula that connects velocity and the radius, velocity. Sorry, we're supposed to calculate the distance. Sorry. Exercise number 5 is saying, we're already done with exercise number 4. We've calculated the radius of curvature. Exercise number 5 is saying, calculate the distance traveled by the point M. The distance traveled by the point M. It is very easy to calculate the distance traveled by the point M. Remember that, this is exercise number 4. Remember that yesterday we said that the magnitude of velocity is equal to ds divided by dt. The magnitude of velocity is equal to ds divided by dt. So if I make ds the subject of the formula, I'm going to get v dt. To get the distance traveled by the point M from its rest position to its final position, I'm supposed to take the integral. So and then because I'm supposed to first of all integrate with respect to t, so it is going to be the integral at some initial time t1 to some final time t2, like so, of v dt. Now, what is the expression? The expression for v. The expression for v is this one. So t1, t2, it is b and then cosine. It is b cosine phi divided by 2, and then of course here we have I've forgotten to write the phi point. So b and then phi point, like so, phi point and then cosine phi divided by 2 dt. This is what we have. Oh, let's remember what phi point is. Now this is the integral between some t1 and some t2. Now remember that phi point is the derivative of phi with respect to time. So here you have cosine phi, like so, and then dt. So this and this can simplify such that you're going to get s is going to be equal to the integral between 0 and pi of b and then cosine phi divided by 2 and then d phi. Now you're asking me, where is the 0 and pi coming from? Well, it's because the dt is going to disappear, and so we're now going to be integrating between, integrating. Of course, I've forgotten to show the screen. So sorry. Remember that yesterday we had this formula for calculating the velocity. How we had this formula for velocity and the Labsis curviligne, how they are connected. We said that v is equal to ds divided by t. Now here we are interested in finding s. So we make ds the subject of the formula. So to be able to find s, we have to take the integral. Because we have dt here, what this indicates is that we are supposed to integrate with respect to t between some initial time t1 and some final time t2. So here we have s is going to be equal to t1 between some time t1 and t2. Then we put the expression for v. We remember that phi point here is actually d phi divided by dt. So this dt and this dt simplify. So because the dt has disappeared, and then we have a d phi here, it means now the integral, we're supposed to integrate between the bounds of what? We're supposed to integrate between the bounds of what? Of phi. So we have b cosine phi divided by 2 d phi. According to what the question is saying, the question is saying that phi is between 0 and pi degrees. Phi is between 0 and pi degrees. Phi is between 0 and pi degrees. So our bounds will be 0 and pi degrees. Like I've indicated here, our bounds will be between 0 and pi degrees. So this is going to be equal to so this is a constant. So if this is a constant, the integral, it's not a constant because this cosine has a phi divided by 2. So remember, let me also remind you that the integral of sine x is going to be equal to the integral of sine x is going to be equal to so the integral of sine x, the integral of sine x is going to be equal to minus cosine x plus c. That is if we don't have any bounds here. But if we're integrating between maybe some bound alpha and some bound beta, like so, then the result here is going to be what? The result is going to be cosine x, like so, and then we have alpha and then beta here. So the integral of cosine x alpha beta is going to be equal to what? Is going to be equal to is going to be equal to sine x, and then here you have your beta and then you have your alpha, like so. Then the integral between alpha and beta of sine tx you're going to get the integral between alpha and the integral between alpha and beta of sine tx is going to be equal to, or it's going to be equal to, so because we have a sine, we'll get a cos. Okay, because we have a sine, we'll get a cos here. That's the first thing that you're supposed to understand. So here you get cos, like so. So you get cos and then t, like so. So cosine t and then tx, like so, minus then between alpha and beta. Okay, so hopefully you remember these things. So this is like some generalization of what we have here. If t is equal to 1, so you say 1 1. If t is equal to 1, you say 1 1. Okay, so you get back the same thing. So here, if you try to integrate what we have here, what are we going to get? So because we have a cos here, so first of all, take the b outside the integral because it's a constant. So here I'm going to have cosine phi divided by 2 d phi, like so. So the integral of cosine, so here what we have is b, say 0 and then pi, and then cosine, and then it is 1 divided by t phi, like so. So this is like our t. Okay, so I just wrote that to remind you. So cosine phi divided by 2 d phi. So the final answer here is going to be, we're going to say this is going to be equal to b. Now because we have a cos, we have to have a sine. We're supposed to have a sine of the same angle that we have here, sine phi divided by 2. Then for integration, sine carries the positive sign. The cos is going to carry the negative. If you integrate cos, you get positive sine. If you integrate positive sine, you get minus cos. Okay, so that's how I remember these things. So sine phi divided by what? Sine phi divided by 2, like so. Then we divide by the t. The t here is 1 divided by 2. Now dividing by 1 over 2 is multiplying by 2 here. Dividing by 1 over 2 is multiplying by what? Is multiplying by 2 here. And between the bounds 0 pi, like so. And then b, so here you're going to have 2b, and then you're going to say sine phi divided by 2, so 0 pi, like so. So here you're going to have, so this is going to be equal to 2b, like so, and then you're going to have sine pi over 2, like so, and then minus sine 0, like so. If you look at your trigonometric circle, sine pi is 1, then sine 0 is 0. So the final answer is going to be 2b. So this is the total distance traveled. So b, remember that b is positive according to what the question is saying. So the total distance traveled here is 2b. So that is all for the first exercise.